Okay, so good morning, everyone. It's a pleasure for me to be here speaking to you on this day promoted by SEPRA, which has organized this webinar on topic of the soil, an increasingly important resource for us, for our being, and especially for the future. So let's start introducing myself. I am Bianca Rompato, a third-year doctoral student at the University of Florence, and I began my doctoral journey in 2021 after my master's degree in forest science. Currently, I specialized in the urban soil and desealing, and the title of my doctoral thesis is Study and Design Urban Soil to Improve Ecosystem Service in Smart Cities. So let's begin by defining urban soil. A first definition of urban soil was given by Crowell in 1992. It consists of no agricultural material having an anthropogenic surface layer of over 15 centimeter thickness, which is produced by mixing, filling, or contaminating the surface of the soil in the urban and suburban areas. Currently, when we talk about urban soils, we refer to a class of anthropogenic soil, strongly influenced by human activity and mainly, but not exclusively, present within urban areas. In fact, they are soils composed of backfill materials and, for example, soils of parks and gardens also close to agricultural soils, but with a different composition, use, and management compared to the agricultural one. And soil resulting from construction or activity within urban area and are often sealed. About your characteristics, urban soil from a physical point of view are characterized by a high content of coarse element resulting from backfill activities. And this determines a strong alteration in terms of texture and thus influencing infiltration process and compaction phenomena. A compaction, in fact, is one of the most serious forms of the soil degradation and consists in the loss of volume at the expense of an increase in mass, with a consequent increase in bulk density and reduction of porosity. This condition results in a loss of structure, reduction of gas flow, reduction of water infiltration, while increasing surface runoff and accumulation of pollutants within water basins. Furthermore, it leads to the increase of the urban heat island effect, influencing soil temperature, microbial activity, and nutrient transformation, and root growth of the plant stock. Bulk density of urban soil is generally around 1.4 or 1.6, and the sealed surface, typical of urban compost or urban context, emphasize the previously mentioned uses. And another physical characteristics of urban soils is the degradation of structure due to a low content of aggregating material. In fact, the high quantity of coarse material, such as the debris or sands resulting from human activities, soil sealing and compaction, limits the development of the humic substance and the organic material, which represent a fundamental component of soil structure. In fact, typical activity of urban expansion process involve vegetation removal or topsoil removal, compaction, construction of architectural works, or backfill. All these compromise the soil structure, which is generally angular block or flat. From a chemical point of view, urban soil are characterized by an alkaline pH and a high content of pollutants, which are derived from human activity. Generally, Urban soil have a pH ranging from 7.4 to 8.6, and the alkaline pH is associated with the large quantity of material derived from construction, such as cement or sand, which release a calcium carbonate into the solution. Urban soil are also characterized by substantial presence of pollutants, both organic or inorganic, and a high content of heavy metals. Both aspects are generated by human activity, which, due to a soil structure, are accumulated or transported to the surface by runoff, thus contaminating small water bases. Another characteristic of urban soil is the reduced activity of biotic component, principally caused by the described feature, accumulation of heavy metals, alkaline pH, and compaction too. About my research, the purpose of my project is to study urban soil in order to increase permeability within the urban context, thus increasing the ecosystem response in relation to the contrast of the extreme flood events, urban heat mitigation, and storage the pollutants. While the objectives are to study desealing in the order to restore soil functionality after a long period of sealing from a circular economy perspective, and study soil restoration in order to minimize the negative impact of compaction through use the urban waste as soil amendments. The proposed study is placed in an innovative thematic context, and in fact, the World Urbanization Prospect predicts that by the 2050, 68% of the world's population will live in the urban area. Although the demographic growth is associated with economic development, this aspect proves to be a problem in terms of land use and compaction. As previously mentioned, compacted or sealed soil can suffer in terms of physical, chemical, and biological properties. In this regard, both Europe and United Nations have shown their intention to stop land consumption by 2050, promoting land use compensation action called No Land Taken, including the sealing and restoration of degraded soil. To a better understanding of a citizen knowledge about urban soil and depaving action, I conducted a survey that received responses from 654 people. I disseminated it through... Sorry? Okay. I disseminated it through various social media channels, main list, and notably with the support of Resoil Foundation. In general, a significant attention from citizens through urban soil has emerged, especially strong predisposition to promote the paving. To promote the paving project or the implementation of green road. However, it is important to know that a significant percentage prefers to support road paving project, as the cost of these fall under the administrative responsibilities. In this context, the need for active collaboration with architects and urban planner is highlighted. About the desealing in the Italian context, desealing is a very expensive action, and the price of disposing the removal asphalt range from 13 to 18 euros per ton, to which the cost of workforce must be added. Furthermore, when the asphalt is removed, new topsoil is generally added, and the cost of which range from 5 to 25 euros per cubic meter. And in this case too, the cost of workforce must be added. My study aims to analyze the desealing process in the municipality of Prato, a small city near to Florence, considering as experimental thesis the addition of milled asphalt into the soil matrix, in order to amortize the cost of the desealing. The objective of the study is to evaluate the suitability of quality as a gross substrate for constructed soil by integrated milled asphalt. This research is motivated by the goal of promoting urban desealing projects while reduction their cost. Before conducting the field experiment, a greenhouse trial was conducted, and we set up a pot test considering 5 treatments in 3 replicates. The images show the quantity of the material used, incremental amount of asphalt mixed with an organic component of urban compost. The experiment lasted for 5 months. However, the most significant finding is that the asphalt concentration used did not lead to any adverse effect, neither in terms of environmental pollution nor in terms in biomass growth. Indeed, both chemical and soil fertility results are more than positive. Furthermore, the analysis conducted on the heavy metal and the polycyclic aromatic hydrocarbon reports parameters that fall within the limits of the national law. This demonstrates that the approach of leaving some of the removed asphalt on the site is viable. And now the field experiment has started in the municipality of Prato, a little city near to Florence, and we prepared the plot of the analysis and saw it the last week. So now we have to collect the data and evaluate the results. With this, I conclude my presentation and thank you for your attention.